Here we're being given a first derivative, g prime of x is equal to the sine of pi x squared, and then a specific interval for which that works. So x values between negative 0.5 and 1.5. And then they want us to determine which interval would that original function g be decreasing. So when we go to read this, remember that we're being given first derivative information. So we can actually read this off a graph. We're going to end up graphing this thing. And when you read a derivative graph, what you want to do is remind yourself that wherever that derivative graph is up in the positive space, that's where your original graph would be increasing. Wherever the graph is down in the negative space, that's where your original graph would be decreasing. And then whenever it hits zero, let's put decreasing right there. Wherever it hits zero, those are your critical values, and those are the places where it could possibly change from increasing to decreasing. It doesn't always have to change, but those are the places that it could potentially change. So to do this problem, luckily for us, we are allowed to use the calculator on this section. So we're not going to need to do any of this work by hand. We're just going to use our calculator to do all the heavy lifting. So what you're going to want to do on this is you're going to start off, and in y1 you will put that original equation, that derivative equation that they're giving us right here. And then because they do want specific values on this, I want to know where those changes are happening. And so in y2 on my calculator, I'm going to put 0 because those potential places where it could change are at those critical values. Then I will graph this. We're going to also want to set our window. So usually before I hit the graph button, I go ahead and set my window because they give us a very specific x window to work from here. So on this problem, we would want to set our x min to equal negative 0.5, and we'd want to set our x max to equal the large side of that interval, which is 1.5. After we graph that, we'll be able to read off the graph where this graph is in the negative space because we want to know where it's decreasing. So we're going to be looking for where it's below the x-axis. And to find those places where it changes, to find those values they are talking about, to know where our interval is occurring, we're just going to calc the intersect between our two graphs. So we'll do a second calc, and then we'll choose the number 5 option, which is intersect. And from there, the calculator will ask us a series of 3 questions. We'll answer them, and that's going to start building our interval for us. So we'll go ahead and start at the beginning. We'll open up our calculator, go to our y equals, and in our first y1, we're going to put that original equation. So the sine of pi x squared. When we're graphing all of our trig functions, all of our graphing on the AP Calc test is always going to be in radian mode. So make sure your calculator is set to radian mode. And then we're going to put 0 in there because that's how we'll find where these two things intersect, where those critical values, those places where it could change, are happening. And then, like I said, because they give us a specific window, before I hit the graph button, I go ahead and adjust that window. So I want an x min of negative 0.5. That's my lower bound. And then the upper bound on this interval is going to be the 1.5 that they give me there. And then I go ahead and graph it. And so what I'm looking for in this is I'm looking for the place where the graph is in the negative because I'm looking for where it's decreasing. So I want to know, where is this graph down below the x-axis? Well, this graph is down below the x-axis starting at this point right here. It's down below and then stops being down below at this point right there. So to find what that specific interval is, that's when we go and use the calc intersect function of our calculator. So we're going to hit second. We'll choose the Calc menu, which is the button above Trace at the very top of the calculator. And inside that menu, you want to choose the number 5 option, which is Intersect. I hit Enter on that, and then you'll see at the bottom of the screen, it's going to ask you a series of 3 questions. The first 2 questions you usually could care less about. It's going to say, is this the first curve? It's on the first curve automatically for you. Go ahead and hit Enter. It'll then switch to the second curve automatically and ask you if this is the second curve. Yep, that's the second curve. Go ahead and hit enter. It's the third question, the guess, that really matters. At this point, we want to guess close to this first point right here, that intersect. So I'm going to scroll so my cursor is near that point. And then I hit enter a third and final time. It'll say the word intersection at the bottom of the screen so you know you did everything right and that the process is complete. And the x value there, that is the intersect we're talking about. So that'll be the starting point of our interval where this graph would begin to go into the decreasing. So we know right now that it would be from 1 and then x, and now we're just going to go find the other part of our interval where it hits that 0 again. So now you just repeat this same process to find the next intersect. You hit second, calc, choose that number 5 option, intersect. And then again, it asks you the same 3 questions. Again, the first 2 we could care less about. Is that the first curve? Yep, hit enter. Is that the second curve? Yep, hit enter. And then it's the third question again that really matters. This time when it asks us to guess, we just need to scroll so we're closer to this other intersect over here. We hit enter a third and final time. It says the word intersection, and that x value is the x value we're looking for. So the AP Calc test is going to round everything to 3 decimals usually, so we would look at this answer as 1.414. And so that's the other half of our interval for where this graph would be decreasing, down there in the negative space. So 1.414 would be the second point. So this is our interval that matches with option C. So remember, when you're going to find where a graph is increasing or decreasing, the intervals on which it's happening, when you have the derivative graph, you read the derivative graph off by remembering that wherever that derivative graph is up in the positive space is where that original graph was increased. Wherever it's in the negative space is where that original graph is decreasing. And wherever it hits that 0, that's the critical values. That's where it possibly could change. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.